Hi, everyone, and welcome to our October belated meetup for the Edinburgh users group. I'm very excited to welcome here our speakers for tonight, Amieroh Abrahams and Marjan van de Weg. So Amieroh is an oceanographer that's working as data scientist at Fathom Data. And she mostly works with R, but also develops training material in other technology at the training wing at Fathom Data. And tonight she'll be telling us about how oceanographers use R to detect impact of climate challenges. And Marjan is senior data consultant at ChangeWorks, which is, for those of you who don't know, a Scottish NGO helping Scotland to try to become more energy efficient and switch to low carbon heating. And she'll tell us about how they use R at an environmental NGO. I'm really excited about both of these talks tonight. Just a quick reminder for those of you that are attending now, this meeting is recorded. So if you plan on asking questions and you don't want to be captured on recording, just keep that in mind or come to us and tell us. We'll try and cut you out. For this time, we'll be taking questions after each of the speakers. And the first speaker tonight will be Amieroh. So welcome, and the stage is yours.
Thank you. Let me just set everything up and share my screen. Can you see it? Great. So thank you for the introduction. So when starting out school, I first heard about climate change or global warming. And apparently it was something that humans created by our way of living. And I was told to turn off the lights and save energy and to recycle paper to save resources. Now, as a child, this left me wondering why there were no restrictions on this and why it was not all over the news. So all of these thoughts brought me here today. Hi, I am Amieroh Abrahams, an oceanographer turned data scientist from Cape Town, South Africa, and I form part of the training wing at Fathom Data, where we develop a bunch of training material from R, Unix, Python, SQL, and basically everything programming. We also offer one-on-one training. So with COVID, a lot of students have been feeling neglected and haven't had the full opportunity or experience to attend courses. By joining Fathom or by becoming one of our clients, we had the opportunity to assist these students and kind of guide them through the process. It's also important to know that the courses that we offer are basically on a certification on completion. You are taught by qualified data scientists, and it's an amazing experience. So please do join it. So this is the amazing team at Fathom Data. We are a mixed bunch, as you can see, and we spread across 3 different continents and 5 countries. So we also diverse in our backgrounds and skill sets.
Live streaming has stopped.
We're also diverse in our backgrounds and skill sets, and over the last few years, we have gained a lot of experience in a range of data science projects.
Hang on a second, I think we've lost the live stream. Let me see if I can get it back. This is not what I wanted to happen. I'm going to just figure out what is going here. Well, this is the problem with using the public Jitsi. Oh, hello. No, it is still live. It is still live. This is really fun. Okay, I'm going to shut up then, and so I apologize for interrupting you. I heard it say the live streaming has stopped, but I can see that I'm still talking on YouTube. So lovely. Isn't public Jitsi wonderful? I'll go back to using my paid-for cluster at some point. Right, I apologize, Amieroh. Please do continue.
No problem. I'll just recap on that. So this is the amazing team at Fathom Data, and we are a mixed bunch. And as you can see, we spread across 3 different continents, 5 different countries. And we're also very diverse in our backgrounds and skill sets. So over the past few years, we have gained a lot of experience in a range of data science projects. And we do a lot of web scraping, we build a lot of databases, and we do a bunch of training. So the topic that I'll be discussing today is basically based on a paper that I published at the beginning of this year. And before we jump into anything, let's get started with some definitions. So the paper focused on eastern boundary upwelling systems, and these are basically cold water blobs in our ocean that cover approximately 1% of the ocean and are defined as the most productive regions in the world. Now, these cold blobs basically originate or are caused by a process called upwelling. And upwelling is driven by wind, right? So changes in upwelling patterns basically influences our upwelling. So in this paper, I focused on the 4 main eastern boundary upwelling systems. And because these regions are quite large, I subdivided them into north and southern regions. Now, about in the 1990s, Bakun hypothesized that an increase in greenhouse gases will result in huge changes in the land-sea pressure gradients, and ultimately would affect wind patterns, which would affect upwelling. Now, in current times, I've decided, okay, let's test this hypothesis and if this theory is actually true. So using sea surface temperature data and wind data, I was able to test if the intensity, duration, and frequency of events changed over time. So first, let's have a look at the methods. So with collection of sea surface temperature are often collected with satellite data products, but also with thermometers and underwater temperature recorders. So in South Africa, we have a group or organization collecting temperatures along the coastline. The only problem with this is that you are not quite certain on whether or not the person actually went to go and collect temperature. Maybe it was like a rainy day and he decided, okay, let me just write in any value and that's that. So given this, we decided, okay, let's stick to using satellite products, which have a constant date and time format, and you have no missing values. And during this process, I used R and certain packages such as Coast R and Heatwave R. So I'm just going to jump into a very quick demo over here. So I'll just run through my steps, but more of this or the exact code for this paper or for these analyses you can find it on GitHub, and you can find this link to GitHub on my paper. So I load in my various packages, and the first step was to download your wind and sea surface temperature data. And because upwelling is affected by wind speed and direction, from these values, we had to determine wind speed and direction. So now I had basically 2 data sets, one data set containing wind and one data set containing sea surface temperature. So then I was required to merge it because both these data have overlapping times. So I was able to merge it, and I just have a subset of the data over here because it's quite a large data set. So I just took one of the regions and only for one particular year. And the data that I downloaded have latitude, longitude. It gives you your V and U variables for wind. It gives you your date, and here we have temperature. And from my U and V variables, I was able to calculate wind speed, direction, and using the date column, I was able to use R to basically extract the months, the years, and I was able to define the seasons. Now, seasons are particularly important because upwelling is mostly dominant within summer. So to kind of to narrow this down to be more specific, I only looked at summer seasons. Now, the main aim was to check if there were any differences between upwelling index, right? And for this, we need wind speed, direction, and the angle of the coastline. Now, there's this really cool package on R called Coast R, where you just insert a bunch of data and it calculates the angle of the coastline for you. So I'm not going to run any of these now because of the size of the data, but I do have a subset over here that I'll just show you guys. So over here, you'll now see that once I ran the Coast R package and I implemented those, I now have the coastal angle over here. So let's go back to our demo. Now that we have coastal angle, wind direction, we were now able to calculate an upwelling index. So I wrote this little function over here, which basically says that if upwelling is greater than a value of 0, we know that upwelling occurred. And if it's less than a value of 0, we know that downwelling occurred. Downwelling is basically the opposite of upwelling. So I just ran the function, got that. And we have a data set called BC upwelling. There we go. So this is the same data set that we had over here. We just have a new column, which is our upwelling index. And it says that, remember that upwelling, if it's less than 0, we know that downwelling is occurring. And if it's greater than 0, upwelling is occurring. And then lastly, we use the heatwave R package. And the heatwave R package is quite simple. There's a bunch of examples on the internet, but you basically only need 2 columns, a date column and a temperature column. And in this case, because we manipulated it slightly, we needed the upwelling index. And you just set a bunch of thresholds and it produces a climatology value. And then furthermore, we can take it further and it produces a nice output. I'm not going to run this once again because the data is quite large, so I'll just show you the output over here. There we go. So after all of those, if you need the script or if you want me to assist you, you can just ping me on my email. But it basically produced a large data set with all the information that we need from latitude to longitude so that we know where this is occurring. It provides us with the duration of the event, the start date, the peak date, and the end date. It also provides us values with the intensity, maximum intensity, and a range of other things. Not all of these were useful to us, so we just, of course, extracted what we need. So let me just jump back to... So after doing all the analyses, we wanted to observe if there are changes in wind patterns over time. Now, with this graph, it basically shows you on the y-axis the various sections of the eastern boundary upwelling systems, and on our x-axis, we have the dates. And as you can see, in this particular region, during these times, there were no drastic change in wind patterns over time. It's important to know these were mainly summer months. So the other months, it could have had some changes or you could have seen some impacts of it. But given this, we decided, okay, if there were no influence or no changes in wind, let's observe if there was any changes in upwelling over time. And here we plot our sea surface temperature over here and a bunch of other variables. And it's important to note that you can see that a drop in sea surface temperature resulted in an increase in upwelling over time. Now, changes in sea surface temperature, of course, are proven to have a large effect on the world, right? And there are a bunch of trends that's been happening within different regions. So as a result of climate change, we are aware that the icebergs are melting. Now, once the icebergs melt, colder water are entering our ocean, right? Now, these cold water are usually at the bottom of our ocean. So you'd see certain cooling trends. But however, at the surface of our ocean, we've been noticing slight warming trends. And the reason for this could be because of a range of climatic influences on it. So climate influences various processes, which ultimately have a large effect on the ocean. So we couldn't basically narrow it down right to winds. But later on in this year, or around March this year, I was looking at various impacts specifically along the South African coastline. And the Benguela current that I was speaking about over here forms part of this region of South Africa, or over here. And you can see that we have a range of cold water and warming events happening. And a lot of the organisms during this time are not necessarily adapted to these changes in temperature, resulting in large effects. So I have a little animation that I'll share with you guys now. So this is a plot that I made. And it basically just plots out how temperature changed in this short period. You can see over here within South Africa, and you can see how drastic increases we had at the same time. But you'll also notice that there's some cold blobs happening during this time. And this is often confusing for a lot of the sea creatures, right? And they aren't able to adapt to these cold temperatures and warm temperatures at the same time. So often these results in a lot of fish deaths happening within our ocean. And this is just in the Cape Town region, part of where you saw the heating happened. And due to a lack of oxygen, a lot of the fish rise up to the surface. And you have these situations when fish are unable to adapt to the changing temperatures, leading into a lot of other conditions. Also, a lot of the fish also washed up on shore, and during the time there were no actual reason for this. A lot of the temperature could be influencing other conditions in the ocean that people are not aware of. So currently a lot of studies are happening on this, and people are researching if it was a salinity issue, if it was actually temperature when fish were unable to adapt to the drastic change. And because these events were happening, people were asked to avoid beaches and to avoid taking or collecting fish at the beaches because they were not certain if they were poisoned or what the cause was. Also, in Cape Town, we had a change in watercolor. So in the previous picture over here, you can see South Africa, or Cape Town particularly, has this dark watercolor. So in the same region, a few days later, we had this beauty. It is a very beautiful color, but it's not the color that it's supposed to be. And this is because of low salinity, low oxygen. It could be because of multiple factors. So during my research, I basically understood that climate change, or the reason or cause for things, were not just focused on one particular scenario, right? So climate change affects a bunch of processes. It affects wind, it affects oceanographic processes, atmospheric processes. So just nailing it down to this particular event or reason was quite difficult. And that's actually why I decided, okay, let's explore the data science field a bit more, because I really enjoyed programming and coding. And it just allows you to look at a bunch of different data and explore so much more. So before I end today's session, I would like to thank my team, Astrid, Gavin, and James, and we form part of the training team. And yeah, if you have any questions, please just ping me. You can also join us at Fathom Data and just pop a question in there if you need any assistance with regards to one-on-one mentoring, or you are interested in joining one of our courses, you can catch us on Fathom Data, and we are more than willing to help you and assist you. Thank you so much.
Thank you very much, Amieroh. So as said earlier, we'll be taking questions now. We do have a few questions from the audience, and I do have a few myself. But in the meantime, if you have any more, just feel free to drop them in the Matrix chat. Amieroh will also be able to pick them up later. So yes. The first question is probably a more statistical one. So can you give us some more details about the modeling behind these phenomena?
Yes. So with modeling, you'll have an assumption that you're trying to predict something. This wasn't actually modeling in the sense. It was more of running data through an algorithm to have like an output. So it's not too much in the modeling field, but more just using an algorithm to determine trends in data. So for this, we did mainly statistical tests that we used. So like linear models, we kept it quite simple just to show some trends.
Okay. Thank you very much. Another question refers to the context. So we have been asked, when did the massive fish deaths start to be reported in the news? When did that happen?
Yeah, around January to March, I've seen it was reported in the news, and this is actually what caught my attention, because all over Twitter and on the Cape Town South African reports, you'd open the newspaper and you'd see, oh wow, there's a lot of fish deaths, and you have this bunch of army people protecting your beaches, and you can't get into it. And I've just been wondering why or what the cause could be for these effects. And that's when I actually started looking at the temperature data. And when I plotted it out or created that animation, I could see that it was heating and then it was cooling. And this could be one of the reasons. So, of course, I'd have a lot of other people saying, no, you need to consider more factors. But this was a quick analysis. And I think that if you are taking a small fish and you are putting it in cold water and warm water and cold water, something that they are not used to, you are going to have it. So roughly from January to March 2021. It has happened before, but this was particularly the one that I was looking at.
Okay, yeah, it's nice that you mentioned that there might be other factors, because there was something that was linking to the animated map that you have prepared, which are excellent for communicating phenomena that evolve over time and possibly showing seasonalities. So I was wondering whether you had considered any kind of seasonalities in currents or
Yes.
any other natural phenomena in your modeling.
Yes. So I haven't looked at any currents or any seasonal things, because this was just me exploring the data as a hobby. But one of my friends or colleagues at the university is actually looking at this more in a deep scale, and he's been looking at kinetic energy and different currents and changes in the speed of the currents and all of that. So he has found some interesting things, but because it's such a unknown phenomenon and it happened so quickly just in this year, it takes some time to kind of pinpoint the thing. But hopefully in future I can come back here and present the real findings.
Absolutely.
Well, it will be someone else's work, but yeah, it will be interesting to know.
So 2 more quick questions, unless there are any more from the audience. So the first one is about what did you use to produce those animated maps? Was it based ggplot, gganimate, or did you use any other package? Or
Yes. So I made use of gganimate, and I just stacked a bunch of pictures on each other. And I actually have the code that I'll share in the chat a bit later this evening, where people can run the data and they can create or reproduce the same map.
Okay, thank you very much. And the other very quick question is also about context, which is this phenomenon of fishes being reported dead and floating. Have you tried looking into other kind of episodes like this around the world, and whether there has been research into that already?
Yes. So while I was reading up, around the same time that this process happened in South Africa, just further up, it happened in Somalia, but towards December.
Mm-hmm.
So it could be that the same phenomena kind of passed from that same area down to South Africa. And so looking at different regions are important to see if it is a process that kind of moved along the coastline, or if it's just something that happened within that region. But yeah, I didn't have much time to look into all of that. But during the same time, it has been, or a few months prior to this event happening in South Africa, it has been reported in different places.
Okay. I can't see any more questions, so please join me thanking Amieroh for her presentation. Thank you so much. And I think now can move on to our next speaker, Marjan. Welcome, Marjan.
Hiya, can you hear me?
Yes, I can. The stage is yours.
Right, I'm just gonna set up my presentation and share the screen. Toggle screen. here you go. So yes, I'm Marjan van der Weg. I'm the senior data consultant at Changeworks. And I have to admit, when I was asked to present today here for you guys, I was first a bit hesitant because I thought, oh, is it going to be interesting enough, you know, in what we do at our charity? Because I used to be in academia where things might have been a little bit more fancy, but then I decided, well, I'll just present some of the things that we do, but also put a bit of emphasis on the differences between, you know, my previous work and the work at Changeworks. So for those of you who don't know Changeworks, oh, I'm trying to click to the next one. Yeah, so we're an environmental charity based in Scotland, and our vision is that the world would be a place where everybody is able to live, work, and enjoy life with a low carbon impact. And the enjoy life part is important because some of our goals are also that we want to reduce fuel poverty. So you can be with a very low carbon impact, mostly because you can't afford to heat. Well, that's not something that we want. So some of our goals are to accelerate the improvement of the energy efficiency of the buildings in Scotland, to deploy effectively renewable and low carbon solutions, and to deliver integrated community approaches to that. And like I said, to reduce fuel poverty. So we have a few different teams that do that. So we have two different teams that deliver insulation and low carbon schemes. So some of those schemes will be subsidized. So few poor areas in the country where people get insulation or solar panels and heat pumps granted with government funding. So we help local authorities manage that. We also have run area-based schemes where we try to help people collectively buy, for example, low carbon technology. So then it's not subsidized, but we try to use economies of scale to establish that. We also have some affordable warmth services. So that's more to help people with who have problems paying for their heat. So we do some advocacy work as well. We run two of the Home Energy Scotland centres in Scotland. So there's 5 centres. We run the one in the southeast in Edinburgh and the one in Inverness for the Highlands and Islands. We are 1/3 of Local Energy Scotland, which is an organisation that tries to help communities who want to have renewable schemes installed for the benefit of their communities to really project manage that, because that can take quite a long time for, say, a rural community to buy a wind turbine from which the profits flow back into the community. And we also own 1/3 of Warmworks, who deliver a big insulation scheme. And then we have a consultancy team. And so there's about 160 people that work for Changeworks, and there's 4 people that really work on data stuff. So when we think about data analysis or using R within this NGO context, it really is a small percentage of the people. And it's also there to enable the delivery of all these things. Oh, I keep on clicking the wrong the wrong screen. So I'm like, why is it not going to the next slide? Okay, next slide. Oh, here we go. Yeah, so my background is actually that I used to work in geosciences. So I did a PhD on the effects of climate change on ecosystems, and I did some postdoctoral work as well. So I used R. I'm self-taught R user, and I used to use it for analyzing the data I'd collected myself, or even to fit different curves through some gas exchange measurements I'd done to get some kind of how do you say, some emission factors, deduce them from those measurements. And I also worked on a project with 2 big databases where I used a lot of R to really deal with that data. So before working for an NGO, that was my background. And when I'm clicking on the wrong screen again. Next one, here we go. So when I was using R as an academic researcher, it really was kind of my toolbox. I used it for all kinds of things. I used it for my data wrangling. I used it for exploring my data, for exploratory analysis. I used it for statistics, of course, for statistical test, hypothesis testing, and to make my visualizations. And if I would compare that to, working at ChangeWorks, it's not so much the whole toolbox. It's kind of like using it as a tool sometimes. So use it for collating certain data sets together, if it's appropriate, exploring certain data and some data analysis. Much less statistics, which is kind of because we're not really doing hypothesis testing at the NGO. We're very much just analysis often is already enough data work to make sure some of these projects are being delivered. So that's definitely a big difference. And we don't really use it for visualization, and there's some reasons for that. And I'll get into that into the next slide. And I'm kind of a bit hesitant almost to say it in an R meetup, but we also kind of use R when we can't do it in Excel, which feels a bit like I'm swearing in a church now, but it's kind of the reality, to be honest. So thinking again of that difference between, being in academia and working at ChangeWorks. Well, when I was doing my own research, I would be able to really decide what would happen. Whereas at the moment in our consultancy team, sometimes the client decides. So the organizations we tend to work with are housing associations and local authorities. So not necessarily places where there's a lot of R-savvy people that you could hand over some code and they'll do it again themselves. So sometimes they explicitly ask for workbooks that they could manipulate a little bit themselves. So that's a big factor in deciding on how we approach a project. When you're doing academic publishing, you think about, the requirements for some of the journals as well. They always want a lot of information in the figures, and it's also the person who has done the research tends to make the graphics, whereas in our case, we often have other team members sometimes that pick up some of the analysis we've done, and then they will be the ones doing the formatting of the actual results. And if they don't have the skills in R, they actually just are quite happy to open up an Excel workbook, do the formatting, and then paste it in a report. And also some of the work we do with the data team is actually picked up by other users in a different team. That at the moment we used Power Platform as our CRM, so that's a Microsoft product, and they have been trained to actually visualize parts of that in Power BI. So that's a choice that's been made elsewhere in the organization, and we kind of get along with that. So we then hand it over. So that's quite a big difference. I'd say one of the biggest difference between my R use before and my R use at the moment. Yeah, and like I already sort of alluded to a little bit too, is that when you're doing your academic research, you might be doing lots of exciting new methods, some more advanced statistics, factors nested in each other when you do your multi-level hierarchical, whatever kinds of regressions you do. Whereas what we do data-wise is actually quite run-of-the-mill at the NGO. It's a little bit less novelty, I'd say, to find there, and that's just the way it is. The attraction is that there's you kind of contribute to something that's actually being delivered in an area in Scotland. We've done a bit of data analysis, and somebody picks that up, and then next year there's 100 new households with solar panels, for example. Yeah, if you get excited about statistics, then I don't think an environmental NGO might not be the place to be working at. So I'll give you actually two examples how we do use R then. So the first thing I'll talk about is some of the monitoring and evaluation that we do in some of the projects that we deliver. So it's one of those insulation schemes that we help local authorities deliver to the public. And we also have been involved in a lot of sort of energy master planning. So local authorities are currently developing local heat and energy efficiency strategies. So that'll be the second example that I'll be talking a bit about how we have used R in the past for this. Oh, I'm clicking again. I keep clicking on the wrong screen. This is the screen that I wanted to. Oh,
It's
here we
fine.
go. Yeah. So, so the monitoring and then evaluation of these insulation schemes. So once people are getting it's mostly wall insulation that they are gifted, either external wall insulation or cavity wall insulation. So there is the question, after they've received that wall insulation, are these households now actually either warmer or using their heating less, which is the whole purpose of getting them to receive those wall insulation. So we have some data that we use for that. So we question the householders about their fuel use before and after. So how much kilowatt hours of gas were they using in the year before they got the wall insulation? How much kilowatt hours of gas were they using afterwards? And then we also have temperature and relative humidity data from monitors. So 10% of the properties that get these wall insulation installed will get monitors in their lounge hall and the bedroom. So that these things called tiny tags. So for example, for Edinburgh Council, we treat about 1,000 properties a year. So that's about 300 monitor files, because 10% of the properties will be monitored. And then there's 3 rooms within each house. And the reason why there's 3 rooms is because there's something called the standard heating regime. So we kind of want to see if the households have more days where they reach the standard heating regime, which is, if you're a non-vulnerable household, it means that you have 9 hours at 21 degrees in your living room and 18 degrees in your other rooms during the week, and 16 hours for the 21 degrees in your living room and 18 degrees in your hall and your bedroom in the weekends. So that's the standard heating regime. There's also some improved heating regimes for vulnerable households, but I don't think that for the purpose of this example, we need to go through all of the heating regimes. But so we kind of want to know, are people warmer, but also do they reach that heating regime? So we kind of want to go from hourly temperature and relative humidity data to daily data. So you'll have a daily average temperature per room and relative humidity. And also if that heating regime was met, so you kind of have to flag, okay, this hour it was above 18 degrees, and then you aggregate it at a daily level. Well, is that 9 hours that it was above 21 degrees and so forth? I actually saw a question combined about the standard target for relative humidity. No, we kind of set that ourselves. So we say that anything between 40% and 60% is a healthy standard heating regime. Sometimes they I don't know how to, the chat keeps coming up. I got a message saying that I should stop watching the chat, but I cannot seem to be closing it down. Actually, maybe I should just close the window. Yeah. I now can't see the chat anymore, but there is we decide the relative humidity healthy regime, but the temperature regime is actually one that is set by the government. So then we have the daily data. Then per address, we'll have data on when did they receive the wall insulation, when did these temperature monitors actually go into their property or not, and when were they taken out. And we can then summarize that in the before or after periods, but also is this the next winter or the next summer, because people use their heating differently in the summer and the winter. And then we report to the local authority actually just some high level statistics, so the insulation scheme level results. So the bit about crunching the numbers from hourly to daily data, we do that in R, but because we keep track of all the data from the households in the Power Platform, and are already the team that is delivering, that's really project managing these insulation schemes, because they work with the Power Platform and Power BI. We slot it into Power BI, so part of it is ends up being processed and linked to the household characteristics in Power BI as well. If it was just a study on people's heating regime after insulation, and it was just one person or two person working on it, you might want to just do everything in R, but the reality is that we don't. So what do I kind of use for it? I just use tidyverse packages, and then particularly also the Lubridate package, because I don't know if anybody is used to working with time-stamped and date-stamped data. It's always a bloody nightmare, you know. So the first thing you do is the files from the temperature monitors, they are all very uniform, so that's very easy to work with. I have a little script. I say, open up the file, skip the first 5 rows because there's nonsense in there, and then use the timestamp to assign it to a weekday or a weekend day, because we kind of need to know that for the heating regime, and then it's just a matter of flagging the hourly data and aggregating that into, or summarizing that to daily, and then address level data. And it works really well for us. It's very scalable. So I think 7 years, when the first time they started monitoring their schemes, they only had 10 monitors in, you know, which is a bit dumb, because it's really not enough to have a good idea about the variability within your between households, because people just use their heating very differently. But they just had an Excel setup. Basically, it was like, oh, we can just, you know, one person can do that, but it's of course not scalable at all to do it in anything else but R, or, you know, you could probably do it in maybe with Python as well. But so we got rid of that Excel bit there, of course, but it works really well because it's very scalable, and because there's such a challenge in the country and in the world to do more of these works. We really want to grow the delivery of these insulation works as well, so it has to be scalable too. And we have similar setups like this for projects that, for example, have solar PV battery or a heat pump installation, where we have half-hourly data of battery use and solar PV use, and maybe they're on a flexible tariff as well. So we analyze that kind of data in a similar way to kind of calculate how many savings people have made. It's almost a similar setup. So I'll move to the next example now. So these local heat and energy efficiency strategies, they're quite interesting in the sense that the government is going to make it a statutory requirement for every local authority to have a strategy and a delivery program ready for basically the coming 20 years on what they're going to do with all the domestic buildings, all the non-domestic buildings, and including the public buildings. So it's both the buildings that the council owns and the buildings that the council doesn't own, that the local authorities will have to plan on what they're going to do with it. So data analysis is important there, because it provides kind of a baseline of, well, where are the most inefficient properties located? So where do we have to do some activities? Which areas also are maybe very fuel poor or very deprived, so we can plan subsidized projects there, or which areas we might have to plan more campaigns and convince people to upgrade their properties. And it's very multidisciplinary. I don't know if it's really interdisciplinary, but I would say there's a lot of analysis of policies as well. It's important to know what the other development plans in the area are as well, and also what the stakeholders in the area want to do, because we can analyze energy demand and heat demand and think, oh, we should really put a heat network here in this village here, because there's a huge ASDA here that could be an anchor load. I'm being very technical now, but if ASDA says we don't care about that, we don't care about putting in a heat network, we're going to offset all our carbon by just buying a few wind turbines, then that falls through. So data analysis forms the basis, but it is really one part of the puzzle. The policies and the other strategies and the stakeholder engagement is important as well. So what kind of is then sort of that housing stock analysis? What does that look like? Well, we will have from a local authority, we'll get their a data set which is not open, so can't really show it or share any examples specifically, but it's the Energy Saving Trust has this data set that the local authority can use, and then we can use it when we help them. So it's about up to, say, 250,000 addresses for say a local authority like Edinburgh, and it has 95 fields with all kinds of details about properties. Are the walls insulated? Is the loft insulated? Does it have double glazing? Is it suitable for, what's the roof angle? Is it suitable for solar PV or not? Is it a listed building? What's the energy efficiency? So analyzing that is really actually quite straightforward. So it's mostly just flagging per address, and then summarizing it per area. So that could be a data zone, which is 360 to 500 households, or sometimes at postcode level. So yeah, you'd have maybe if the wall construction is cavity construction and it's uninsulated and it's older than 1994, then flag it for cavity wall insulation. And then for other kinds of wall insulation or other kinds of heating systems, we have a similar kind of code. So it's really not rocket science, to be honest. It's very repeatable. It's also quite a tested method, in a sense that almost everybody that would analyze that data would come to the same conclusion. It's not very controversial to say that a south-facing roof on a non-listed house would be suitable for solar PV, for example, for solar panels. The only interesting thing is that we have our script. We've helped last year. We helped 6 local authorities do a pilot project on creating these strategies. The year before it was 4, and the year before a few other ones. And so we've been using because it's quick and all these kinds of things. But interesting enough, this year the Scottish government has developed a standard standard tool to do these analyses. So these strategies, they're going to be a statutory requirement for the local authorities, but the government realizes that the data skills might not be present in the local authorities themselves, so they want to offer them standard methodologies and standard tools. And the tools that we are going to test this year is an Excel tool. It's huge. I'm not going to be too complaining about it, but it's interesting that we're actually for these pilots. So this year we're already going to do help 4 different local authorities, maybe 1 or 2 more this year. We're going to have to test these Excel tools and report back. So if I do have complaints, I can report back. So that was just a bit of a fly through some of the things we do. So I think, at ChangeWorks, the data analysis itself is not so much a service that we offer. It's very much, we do it to enable to sort of carry out our charitable goals. And the the extent of our use is not so much determined by the versatility of R itself, which is, as you all know, is huge, but it's very much sometimes determined by the context. So either the client asks, or skills of other team members or other people in the organization, or, as I just mentioned, prescribed methods. And it adds most value when we are enabling the scaling of data analysis. And it seems that there's a word that's fallen off my slide here. I'm very sorry. The scaling of data analysis of very large data sets. I think that's what I wanted to say. So that was what I had to say in my presentation. I'm happy to take questions. Here we
Thank
go.
you very much, Marjan. This was a very, very interesting talk. So we do already have a couple of questions, although I hope more will come from the Matrix room. So I guess a few points relate to the use of Excel, right? So there's always been some debate about consistency and reliability of using that kind of tool for research purposes, or even just keeping numbers and tabs. And now you're telling us that there's a push to make this into a compulsory tool to be used by local authorities through macros and whatnot. So well, do you have any comment on that? Well, what do you feel this will lead to?
Yeah, well, I have to set the record straight. The tool is not going to be compulsory to use. It's because we are testing it out as a pilot that we've been asked to use it this year. So I don't want to go on the record and say, oh, the Scottish government is telling local authorities they can only use this. In the end, it'll be the local authorities how do you say that, they'll have to find a way to do it, and a method and a tool has been developed for them. And this sort of pilot round, we're going to test out the tool for them. I think the intention behind it is noble. They want to make it easier, but it's a huge file. Some of the files are going to be that they're going to add to the tool are big as well. So I don't know how usable it is. Also, if you put in a thing with some macros with some buttons, and if it breaks, people won't be able to repair it. So I'm not a fan.
Do you know if the tool will be made accessible to third parties? Will it be open, or?
I'm not sure. I think part of it might, because the data that goes into it, the data sets that the address data set is not going to be open. They might say, well, there's no use in making the tool open. The logic behind all those, well, if it's a property with this, then do this. That's all quite. I think those methodologies might become open. They're similar to how we've always done housing stock analysis, because we've compared them in the past with a similar tool that had been made before.
Okay, thank you very much. Another question. This time, this comes from myself. I have been working with the Est Data as well in my job, and I have to say there are quite a lot of question marks over how some of the information is recorded, especially about the temporality of some of these. In particular, we are working on heat pump installations, for example, and the measurements regarding house efficiency and insulation and everything else are updated as soon as there is a heat pump installation. So the data set basically only contains either the last records or a number of duplicates that you quite can't use. And on top of that, there's quite some debate about how reliable the EPC data actually is in telling us about home efficiency. So do you have any comments on that? How did you deal with this kind of problems in your work?
Yeah, oh gosh, we can talk an hour about EPCs and not be done. within the energy efficiency community, there's tons of talk about EPCs and how good they are, and they depend a lot on also how good the surveyor has estimated, for example, wall thickness. If it's quite a bit of sensitivity there around, especially like pre-1919 stone built properties, that if you estimate this, and I can't remember who estimated it or where I heard it. I heard it at a EPC chat where basically if the walls are estimated to be too thin, the heat loss is overestimated, of course. And I think in terms of some of this data not being completely accurate, when it comes to making a strategy for a whole local authority, that average middle of the road local authority has 120,000 addresses, properties, domestic properties. If you have a few streets that have not been, that have iffy data, then it doesn't matter that much for your overall planning. It is when you start using that data to really plan at a street level, like, okay, now we're going to do this here. And there's some reasons why I know, because we've talked to EST a few times about some of the mistakes that are in the data. I'm sorry if I go into too much detail. It's just that I could talk about this for an hour, honestly, about EPC data. And some EPC data had, say, if you have a terraced group of houses, there were external walls and there were walls in between the properties. For a whole area once in Perth, I think the EPCs were all submitted at once, and the system had mistaken the internal walls for external walls. So they showed up in the data all as being uninsulated brick properties when they were actually cavity wall filled properties. So yeah, there's ways that sometimes the processing in that data set shows up or puts in an error. There's also some of their statistical modeling that puts in some error as well, because say 53% of the properties have an EPC record. So for the other 48%, it is statistically modeled. And for some, say if you have an area where that looks alike, you're in an urban area, we have an estate, you can much more, it's much easier to extrapolate the kind of properties, because it'll look like the neighbor. If you're in rural Shetland, I don't know what they live in, but they sometimes just look like sheds, So no offense. I hope there's no people from Shetland.
No, but that makes perfect sense. I mean, it's a classical statistical problem. What kind of donor do you take to infer or extrapolate something about something you haven't observed? Of course. Okay, thank you very much. This was a very interesting answer. We have another question about what kind of sensor technology you have been using. And on top of that, I would add, are you also utilizing data from smart meters that are already installed in the houses, or is that something different?
Yeah, so for smart meters, we've not really had a need yet to use smart meter technology, because we tend to just are interested in the before and an after. We don't have any projects at the moment where we will monitor things very closely and then make a decision and intervene, or so. Which is also the reason why our temperature monitors they're offline, because then it's just cheaper, because the monitoring and evaluation on these projects is actually just a small part of the budget. Say Edinburgh Council wall insulation is, say it's a 5 million project for a year. The money spent on the most of the money is spent on making it happen, and then the monitoring and evaluation is a small part. And because we only look at it once afterwards, if those monitors have been in there for quite a while, we'll take them out again, make sure that they've been in beforehand also long enough. It doesn't really warrant more expensive monitors that you could log into, because we're not doing anything. We're not tracking it and then telling people you should turn your heating off or on or off. There's
Why not?
no decision based. Why
I mean,
not?
I guess it could
actually,
be interesting to try and study the consumption
definitely.
behavior of households and see maybe to build a
Yep.
recommendation system or something. But it's
Mhm.
bound to be very
and I think there's
complicated.
actually some off-the-shelf stuff there. There is Switchy, I think, is a company that does that with
all right.
housing associations.
Mm-hmm.
So there's a housing associations that use some monitors where there is feedback and we've not really offered that because it's not been asked of us yet. We've not been involved, and I think, but we have had talks with a product, and it's also then, well, if the product exists or if there's already then maybe the housing association or the council should actually just spend their money on that rather than us reinventing the wheel.
Yeah, get it.
Yeah.
Okay, thank you. Actually, we have a question that probably came in earlier, but I missed it. It's still, I think, about the EPC, Est Data reliability discussion. So will data checks and validation that could pick up such issues be included in the local authority tool, the Excel one that you were mentioning?
Well, we tend to do it ourselves, so I'm not sure if it's in a tool. So we do sense check the data with just, also Google Street View sometimes, and if things don't make sense, and then often we kind of know the data well enough now that we can that we know what the problem can be. So sometimes things show up as flats when they're actually terraced houses, and it's when there's a terraced houses that have a little close on the ground floor. This is all very detailed and technical, but so we do we at Changeworks, our methodology is going through sense checking you can't have loft insulation recommended for a ground floor flat because they don't have a loft. They have a thing above them, so simple things like that. Or we know for certain ages, this property age, certain wall types just don't happen after a certain certain age. So we do, and if weird things show up, the first thing we tend to do is just go Google Street View or check the EPC register, but that just comes as a PDF, so that's harder to query.
Okay, thank you very much. So let me just quickly check if there's any last second question, but I think I haven't seen any. So I would like to thank you and Amieroh, our speaker, for two very, very interesting talks tonight. And I think we can wrap this up. We are 2 minutes over time, which is perfect.
Oh, sorry. I hope I didn't go off the rails talking about EPCs.
No problem at all. No problem at all. We're not physically keeping anybody in here, so it's absolutely no problem. Okay, so thank you very much. And I would like to remind everyone that we are always on the lookout for new speakers. So if you have something you'd like to tell us about, which is R related, just feel free to get in touch. We'll find a spot for you in the months to come. And thanks again, Marjan and Amieroh.
No problem.
Goodbye. Till next time.
And don't forget, the chat will continue in Matrix in the meantime. Please do join us and be a part of it. And thank you also from me for the speakers, and see you all next time.
Bye-bye.
Stream finished.